nice. Look, everything I circled, those are the ones we're going to do, all right? So, let's get started. Everybody, anytime we have problems, I know that your brain is all over the place because it's a lot, but I need you to kind of pause, look at the problem, look at the radical, and then ask yourself, okay, what radical index am I looking at? So if it's 2, I'm going to be looking at my list of squares. I said squares in my mind, but didn't come out. Always bring the number that's right here down. Anytime you have a number that's right there, go ahead and bring it down because you're not going to do anything with it initially. But this will have to be split. So I need you to do a radical for what's perfect and a radical for the leftover. 294.
49
Say again.
49
Thank you. Give me a solid. 294 becomes 49 times 6. Do you understand where I got that from? I just split the number. Now for the letters, I need multiples of 2. Yes? Multiples of 2 because that's what the index is there. Now, what will that give me for the M? M16. And then what will I put for the N? N6. And then what's left over? Yo, I got something left over here. I got to put just the N, okay? You know, every time we do this, this will come down and just each notch, okay? It's not going to change. What's in the first one will, because I'm going to take the square root of 49. And what will I get? 7.
Can I get Bryson one to check out, please?
Yes.
Thank you.
This becomes 7, but y'all, multiply it by what's already there. And that's going to give me a negative 14. Thank you. And I have to take what's left here. Y'all see this index? I'll zoom in on this. My index goes under the 16, under the 6, okay? That's going to give me M8 and N3. That is so sloppy. Let me circle that. There you go. That's your answer. Negative 14, M8, N3, and then the radical 6N. I promise I will write the next one a lot neater. Do you have that? Now, I'm not going to wait for you to take pictures of the screen because I told you I'm going to post this. So you'll be able to, like, mute me and zoom along if you want to later. So I'm skipping number 2 and number 3, unless you have a question of where to start on those. But see, next class, don't forget the project is due. Number 2 and number 3, you will work just like number 1, except number 2, you have an index of 3, so I want you to look at my cube list. And then number 3, your index is 4, so look at the list of fourths. Now, taking us to number 4, I think I have that one circled. We have to first do some simplifying before we can combine like terms. So anything that can be simplified and broke down, we gotta do that. I cannot simplify the square root of 6, y'all, because if you're looking at my perfect squares, there's nothing that can go into 6. So I'm just gonna leave this alone, bring down the radical, bring down the square root of 6, and then let's work on the 45, bring down the negative 3, and when you split the square root of 45, it's 9 times 5. I want this to become muscle memory where your brain can immediately tell me the 2 numbers, at least for the squares. Sometimes the cubes and fourths are harder, but for the squares, I really want you to try to get those quickly in your head. 96 might be a little more difficult. I think it's 16 and 6. Oh, it's 6 and what? Yes. I bring down my 2. And this becomes, I want to put the 16 first only because it's perfect. And whenever I bring out what's perfect, I need to remember to multiply it by what's already there. So that's the only reason why I like to put the one that's perfect first, okay? Hey.
If you need a, only come if you are getting a staff lunch and you bring it back to the room.
What?
Anybody get a stack lunch? Okay.
Y'all must just be waiting to go on me.
No, nobody want that cold liquor. All they do is throw ham on bread.
Yeah, and a piece of hair.
Stop dancing. Oh my gosh. Gosh, y'all be so funny sometimes. Like, do not. Like, oh my gosh. Square root of 9. Square root of 9. Let me focus. I can't. I gotta get done. It's 11:58. Square root of 9 is going to become 3. You understand? So I'm going to circle this and cross it out. And that way you'll know what happened to the square root of 9. So it becomes 3. But anytime you have something that's out here, you multiply it by what's already there. So these multiplied together is going to give me a negative 9. And then bring down the radical 5. And then look, I have a square root of 16 that I have to simplify. Do you know what square root of 16 is? Good. So this crosses out. It becomes 4, but I multiply it by the 2 that's already there. So I now have 8. And then I bring down the radical 6 again. When you get to this point, I need you to think about like terms. So I'm going to give you something to relate. If you had negative 6x and, I don't know, positive 4x, those are like terms. You would just take these numbers here and subtract, and you'd have 2 and then keep the x. All right, now let's relate that to radicals. When you have like terms with radicals, the radical has to be the same. So that means you have one here that's the square root of 6, and you have one here that's the square root of 6. You got to take their coefficients and then add or subtract them, but leave the radical. There is an invisible number. Do you see it? What's the invisible number? So right here, that's going to be a negative 1, and then look at the other one. That's a positive 8. Negative 1, positive 8 is going to give me a 7. So I have a 7 for my coefficient, but I have to leave this alone. Is there something I can put with the square root of 5? So that means I just got to bring this one down, and I'm done. That's your final answer, okay? Again, I'm not going to pause and all that. You can ask me about how I got something, but you can copy it on your own if you didn't get that copy. All right, let me zoom out for a second, and you can tell me if you had a question about starting number 5, because I didn't have it on my list. But you know where to start, right? All right, you have to split it. Yep, just like I did on number 4. All right, so jump down to number 6. This is when you multiply. When you multiply, do not immediately start by simplifying. That's not what we do. When we multiply with radicals, you can make yourself a note. All you have to do is multiply what's outside, and then multiply inside, and then simplify. So that means I'm going to say, oh, well, there's invisible ones, so multiplying those ain't gonna make a difference, all right? So the invisible ones do nothing, but that means I have to multiply this and this. Multiplying numbers, just multiply like you normally do. Negative 12 times 4 is negative 48, right? So I'm going to keep the radical, and I'm going to have negative 48. And then when you multiply the letters, what do you do with the exponents? We're going to add them. x4 and x2 is x6. y1 and y2 is y3. Now, y'all, I need some muscle memory to kick in, because all I'm going to do here is split it. When I split this, I need to look at my list of cubes. On the board here, my list of cubes, I know that 8 can go into 48, so it's going to have to be 8 and 6. Where does the negative sign always go? With the first one. So go ahead and do your 2 radicals for the split. Put what's perfect in the first, leftovers in the second, and I always put the negative sign with the first one.
So you multiply the normal numbers by the variable you just added?
Yes. So, I forgot what I was doing. Splitting the 48, or the negative 48, gives me a negative 8 in this one, and then the 6 goes in this one. And sometimes you might just need to look back and say, okay, does negative 8 times 6 give me negative 48? Yes, it does, so I'm good. What do I do with the variables? Please tell me you remember. I'm looking for what? Multiples of 3. Are these multiples of 3? They are. So that means I'm just gonna put x6, y3. And now the leftovers stays in the radical. But the first one, you gotta take the cube root of the number and then divide the exponents by that number outside, all right? So I'm gonna say cube root of -8, which is -2. But then I gotta take this 3, put it under here, put it under here. X squared y. Good job. All right. So I had them ask me about number 7 in my last class. Oh, I think it was number 7. It was one we had to distribute. Yeah, they asked me about number 7, and we worked that one, even though it wasn't circled. Do you want that one, or do you want me to go ahead and jump to number 8? Look at number 7. Do you want that one?
Yeah.
Okay. All right, so when we do this, again, with multiplying, it's outside times outside, inside times inside. Now, I got this times this. Obviously, the 18's inside the radical, so there's nothing that I'm going to do to the 18. That means I got to put the 5 in the front and then the 18 like this, okay? So this time, though, when I multiply the 18 and the 2, they're both in the radical, all right? So I'm going to put my negative sign, and the square root of 18 times square root of 2 will give me the square root of 36. Since there's nothing to do with this part at the end, I just need you to bring it down. All right, tell me what you're thinking before I proceed. We good on that so far? Now, once you've done the multiplying, this is the step where we start splitting apart. We want to get what can be simplified, what's perfect, we need to split it and all that good stuff. So I leave the 5 alone, but then the square root of 18 becomes what times what? 9 times 2. I'm going to go ahead and simplify this, because this is perfect. What is the square root of 36? Okay, don't forget the negative sign. And then, can I do anything with that? No. This is just going to come down as the square root, or I'm sorry, -11 times square root of 2. Now go back to this. You have the square root of 9, which will become what? Cross it out, and now I'm going to take 3 times the 5, which gives me 15. Bring down the radical 2. Bring down the other one, which is the -6, okay? And bring down the -11 with the other radical 2. You know I have issues, so I have to have it in the same color. We look for like terms, just like I did on the other problem. This has a radical 2, so does this. So that means those are like terms, all right? I say what? 15 minus 11, which gives me 4, and I'm going to leave the radical 2 alone. And what about the 6? Just bring it down. I'm done with number 7. So let me say number 8 is a binomial times a binomial. Whenever you see these problems, immediately you got to think about FOIL. When I do FOIL, I only do it using the box method. I just love it. I have issues, but the box method is neat. I love how organized it is. So that's what I'm going to do. I don't know why, for some reason, my brain sometimes gets mixed up when I'm doing all that distributing with radicals, because I forget what's in the radical and what's outside the radical. That's the only reason why I prefer doing the box. Draw your box, and then whatever you have, the things that you're multiplying are going to go top and side. So that means like this here, I'm going to put here. And then this here, I'm going to put here. Got it? Yes? All right. Outside, inside times inside. So, first box. 2 square root of 9. -5 square root of 18. 2 square root of 18. negative 5 square root 36. Question so far. There's a lot more to simplify. What happens in this top corner box that I'm pointing at right here with that 2 and 9? It becomes what?
3.
It becomes 3. So that means if this becomes 3, then this box here will now be 6. I'm circling that. It's 6. Don't even look at what you had before. It is 6. Do this box right here at the bottom. The square root of 36 becomes, so if this becomes 6, then this box becomes negative 30. Don't look at what you had. It is now negative 30. So I know that these don't have radicals. We can go ahead and slap that over to the side. 6 minus 30 is negative 24. But then this here, these are like terms because they both have a radical 18. Negative 5 plus 2 is going to be negative 3. And then keep the radical 18. This is the part where some of you are going to lose credit because if you don't see that this can be simplified farther, it's going to be kind of like a -1 or -2. No, please don't do that.
No.
Split the 18. Y'all, please do not subtract those numbers because 24 doesn't have a radical. Got it? If 24 doesn't have a radical, I can't subtract it into 3. So you're going to actually leave this alone. You're going to bring this down, but then I'm going to take this 18 and my 18 will split. So this will now become the square root of 9 times the square root of 2. And I can simplify the square root of 9 because the square root of 9 is 3. 3 times 3 is negative 9. And everything else that was above, I just need to bring it down. Bring down the negative 24, bring down the radical 2. Do not try to go any farther. They are not like terms, so you cannot go any farther. Stop here. Yes? All right, so on number 9, I'm not working it, but you know you got to expand it, right? When I say expand it, that means write it twice and do a box. Y'all are just about to die with them phones now. Them phones ain't gonna save you test day. Please, please, y'all, lock in. I'm not working it. I'm just reminding you when you set it up that you need to do the box, okay? All right, next page. I know, it's a lot, it's a lot, it's a lot. Well, I'm trying my best to help you out here. On this page, I have a few selected that I'm desperate to go over with you because I just have a feeling you may have forgotten how to do them with the fractions and the radical. So I put on here number 12. I skipped number 11, but then like I'm thinking maybe in case you forgot, you could just listen to the reminder that we're dividing the 112 by the 7. And then with the variable, see how you're subtracting the exponents, okay? And then proceed, all right? Yes? Let's get to the ones I feel that are a little more difficult. Number 12, yeah, on that, number 11, you just divide that. And it will be this here, whatever 112 divided by 7 is. I can't remember. Thank you, baby. And then this will just be A, 4, B, 9, and then finish, because that is not done. That's not done. You gotta finish it. I cannot lose track of these. I gotta get here. So, sorry. I'm going to number 12, and I can answer number 11 next time before the test if you need me to go through that step by step. But this is important. Number 12. You know that 7 cannot divide by 56 evenly. Not evenly. But it will be a fraction. Let's say we reduce 7 over 56. What will it become? 1 over 8. So that means I have the cube root of 1 over the cube root of 8. Do you see what I did with that? All I did was put the 7 over 56 like in my brain and reduced it, okay? Now look at those numbers. Those are perfect cubes. What's the cube root of 1? What's the cube root of 8? There you go. That's it. Yes? So, this was not on the list, but I wanted to work this one because it's kind of like number 12. If you would just look at the 6 and the 15, and let's simplify that. Because I know you know that we cannot keep the radical. You cannot keep the radical at the bottom. Never keep a radical at the bottom. But I want you to make the number smaller so it's easier to work with. Take 6 and 15, divide that, and tell me what the fraction would be. 2 over 5. So I'm going to ask you to write this, and I want you to write the square root of 2 over the square root of 5. All I did was reduce it. Now, do you remember how to get the radical gone in the denominator?
Don't you like multiply by yeah.
Yes.
5.
Multiply by the radical 5. So I'm going to take the denominator, which is the square root of 5, and multiply the top and the bottom by the square root of 5.
Teachers and students, pardon interruption, we're drawing closer to dismissal at 12:30. At this time, if there's any student that did not get lunch and you want to get your lunch at this time.
Outside time, outside, inside times inside.
Out of lunch, you come to the lunchroom
So
at this time, grab it, go, and get back to class. Thank you.
Thank you. You do that. She said, I thought you make it a negative. You do that with problems like number 17. See how number 17 has 2 terms? That's when we change the sign. I'm glad you said something. Now, back to this, it's actually a little easier. So when you multiply this, outside times outside is a 5, but then inside times inside is the square root of 10. This one becomes the square root of 25, which is a perfect square. What is the square root of 25? It's 5. So that means I'm going to leave 5 times the square root of 10 here. The denominator will become 5. Do you see anything else you think I can do? Cross out the 5s. There's your final answer. That's it.
Miss Brisher, how about kind of Miss Brisher, we kind of got the 10.
I can put it in a pass, I don't care, you can go first.
Yeah, you can do this. You go ahead, okay? And, you know, I have this, so I'm gonna post this on Canvas, okay? So you can go back and look at this. I'm gonna post it on Canvas, all right? What I got here, number 14. Can you see the same thing happening again with the 10 and the 18? What did I tell you have to do? Reduce it. 10 over 18 becomes 5 over 9, yes. So I have the square root of 5 and the square root of 9. Do you know what to do with the exponents? Did y'all say what? Subtract? Subtract them? Yes. So that means I have 3 minus 1. What's 3 minus 1? 2. So that's going to be m to the second power on the top, okay? From here, can you take the square root of 9?
Oh,
Yes. What does it become?
3.
Can I split this? Can I split the square root of 5m squared? Yes. Let me show you how. You know you can split it. What's perfect goes in the first, what's not goes in the second. 5 is not a perfect square. It can't be split. But this is a perfect square because I need multiples of 2, and that's a multiple of 2. So that means this will become m. This will stay in the radical.
Pardon interruption, just wanted to make a few bus announcements as we approach dismissal today. Route 75 is on sub bus 80. Route 93 is on bus 124. Again, 75 is on bus 80. Route 93 is on bus 124, so make sure you pay attention to those changes. Teachers, I need your help. If you did not come by the office to physically sign for the dyslexia training, please do that for me before
Number
you
17.
leave the building today. Help me with that, I appreciate your help. In just a few minutes.
This is the
we'll
one that-
call in for dismissal, so hang tight, and let's be safe tonight, and have a great night. Go Mavs.
Jesus, he's talking a lot.
Okay, so look, gotta get rid of the radical here. If I multiply by just the square root of 7, that's not gonna get rid of the radical, because I'm gonna end up having to put it with the 5 too, so it's not gonna be gone. Change the sign.
You know, first of all, I agree.
Yes. This is the thing that Lily was saying. It will now become a plus sign, right? And it will be times this here.
I started with it.
That's fine, baby. And then this will be 5 plus square root of 7 here. You know this means I have to do a box for the top, a box for the bottom. Please do not act like it is a big deal. I promise it's not. This right here, I'm gonna do a box for. All right? Kind of like that. And I'm gonna have 2 plus the square root of 7 here. 5 square root of 7 here. Outside times outside, inside times inside. This becomes 10, 2 radical 7, 5 radical 7, and radical 49. Now we're gonna simplify. Let me know when you're ready. That goes together, giving me 7 times the square root of 7. But what does the square root of 49 become? So now I have 10 plus 7, which is 17. Got it? Yeah, let's do the bottom. Yeah, we gotta do this one now, okay? So I'm gonna do my box for the bottom.
I brought my place today.
I'll be extra with mine, I know. 5 minus radical 7, 5 plus radical 7, and that's gonna be 25. Square root of 49, check my math. We know that the bottom has to cancel radicals out. So these better cancel. All right, now this will become 7. So I have -7 here at the bottom, all right? -7 and a 25 is 18. Yeah. And that means my denominator is 18. Y'all, there's nothing I can do with this. I'm completely done with that, okay? I hate so much that I'm only gonna have time for one more problem. So we're gonna make it a good one. On the back side. So this is basically where the other class left off. We did not have time for all of them, so I let them choose between 27, 30, and 31. They picked 27 and 31, but we won't have time. So let's just do 27. 30 is easy. I promise you. It looks difficult, but 30 is easy. Because, well, I don't know, maybe it's not. Oh, Jesus. So look, first, get rid of this negative. How? By putting it in the denominator. So this here, 81, in parentheses, right here, put at the bottom, and now it's going to become a positive 1/4. Stop and process that. Do you get what I'm saying? Please don't pack up right now. Please write these down. Now, I'm going to get rid of the fraction for the exponent. How I do that is by taking the 4 out to become my index. And then it's going to be, y'all pay attention to this, 81 to the 8th power. You got 2 options. You can take the 4 and divide the 8, or you can go in your calculator and press the 4th root of 81 to the 8th power. Now, mind you, this is just the bottom. We still have a 1 on top. Okay, don't forget, we still have this on top, all right? But do you know how to put this in the calculator to do this? You press math 5, and then you have to change the index to 4. And literally, you will put the 4th root of 81 to the 8th power in your calculator.
I did not know that.
Uh-huh. And it becomes 6561. So I got 1 over 6561. That's it. Got it?
That's the answer.
Yes, that is the answer. And I'm sorry I didn't have time to work the other 2. Matter of fact, what I probably will do is finish them up after the bell rings and then post it.